Hi everyone, I am Siddhant Attavar and I will be talking about my project SMART, Stroke Monitoring and Rehabilitation using Technology. My interest in this subject was triggered when a close relative suffered a cerebral stroke and began undergoing a painfully long rehabilitation process. She often spoke about the challenges she faced, the high rehabilitation costs, and the difficulties associated with traveling long distances to rehabilitation centers. As I researched in stroke statistics mentioned here, I realized that stroke rehabilitation is indeed a major global healthcare challenge. Stroke rehabilitation poses even more of a challenge in low-income countries like India due to lack of awareness about stroke symptoms, high rehabilitation costs, and a large rural population with limited healthcare facilities. My project SMART is an attempt to address these very challenges. I believe it is an innovative, low-cost solution that will facilitate rehabilitation at home and thereby radically change how stroke care is delivered. The SMART package consists of two parts: a DIY EEG headset that records brainwave activity and a smartphone app that analyzes it. EEG is a non-invasive method of monitoring brainwave activity. However, medical EEG devices are not suitable for home use. So, we have designed a DIY EEG headset using 3D printing and low-cost electronic circuits. The headset is designed to be easy to use, rugged, and be able to fit varying head sizes. Following extensive research, I identified certain low-cost and easily sourced electronic components to build the Smart EEG headset. 3 silver chloride electrodes placed on the forehead and behind the ears and the mastoids. A microelectronica 3359 IC for amplification and filtration of the weak bias signals. This IC consists of an instrumentation amplifier which amplifies a signal by a factor of 12x, and the filtration module which amplifies the signal further and uses low pass and high pass filters to eliminate noise interference. Finally, we have the Bluetooth enabled Arduino board for collecting and transmitting the signal to the Smart app. The EEG data collected by the Smart headset is relayed via Bluetooth to the Smart app. I have developed an algorithm in the Smart app which analyzes the raw EEG data by performing a fast Fourier transform or FFT. The frequency spectrum is then divided into alpha, beta, theta, and delta brainwave bands. The Smart app has been designed using Android Studio. It is easy for patients to use at home and for doctors to remotely monitor the patient's progress. With just a few clicks, the patient can access diagnostic tests, rehabilitation modules, and take charge of monitoring his own recovery process. To prevent brain damage, it is crucial that stroke is diagnosed quickly. In remote healthcare centers, SMART offers a low-cost and portable method of screening patients. This can be a lifesaver in rural areas where sophisticated diagnostic techniques like MRI and CT scans are expensive and not accessible. Studies show that the delta-alpha ratio can also be used as a marker for the diagnosis of stroke. I have designed a simple, portable, EEG-based diagnostic test that measures the delta-alpha ratio to identify stroke patients. According to recent research, high levels of alpha activity are associated with positive rehabilitation outcomes. I have designed a simple, interactive game that trains patients to maintain high levels of alpha activity using neurofeedback training. This game uses SSVP, or steady state visually evoked potentials, to induce the alpha brainwave state. In order to test the reliability of the Smart EEG headset, I performed a series of tests. First, I compared the raw EEG data from the Smart EEG headset with that from an external dataset, confirming that both readings were in the same range. For the second experiment, I used an SSVP to test whether the Smart EEG headset is able to detect changes in the brain state of the patient. I first recorded the beta level of the subject with no external stimuli. I then introduced an SSVP to increase the beta level of that subject. As we can see in the graph, this change was immediately recorded by the Smart EEG headset. In conclusion, I believe that SMART can help improve the quality of life for millions of stroke patients across the world due to 4 reasons. It is a low-cost solution, less than $100. It provides diagnostic tests to identify stroke early. It allows doctors to remotely monitor the progress of a large number of patients at once. And last but not the least, SMART makes the patient an active participant and gives him control over his rehabilitation process. Experts say that this psychological factor itself can significantly improve patient recovery outcomes. Thank you.